We have a force stretching a wire that's fixed at one end. And so we have a wire fixed at one end, and it is stretched. The value of the force increases from 0. So we have F equals 0, and then we have F equals, so maximum. And then it is returned to 0 force. Now we're making inferences here about the length. We're just talking about the magnitude of the forces. The graph shows the variation of force with the extension of the wire, so Fx. So we should be thinking Hooke's law kind of situation. We lay out our oizerga. Origin, 0, 0. That's easy to find. The y-axis is x, which we assume would be measured in meters. X-axis is force, which we assume would be measured in newtons. The intercepts, there are two. There is a 0, 0 and a value of 0, a y-intercept of, say, 0, maybe 4. We'll give it a number. Things we could read from this graph are x and f. The slope is delta x over delta f, which is meters per newton. Newtons per meter is the spring constant. The slope, then, is 1 over the spring constant. The area, F times X, has units of Newton meters. What we want to be careful of in this case is that we usually expect our force distance graph to look like this. And we see that the axes being flipped, we get 1 over the spring constant is the slope. Which area represents the net work done on the wire by the force? One simple way to interpret this graph a lot more easily is to redraw it the way we would like to see it. This becomes x, this becomes f. We have a point at 0, 0, and we have a point way out here, xf, where they all converge on that point. When we redraw these, we get this curve and this curve. This area corresponds to P, this corresponds to Q, and this corresponds to R. In terms of the arrows, the P curve that borders the P has the going out, and the R curve is the coming back. What it appears then is on the way out, we have this force times distance, the area, would look like this. But then we made measurements on the way back, and it followed this curve. In the end, the remaining area we have is R. We might have done that work along the PQ boundary, but it's the return value that shows us the work that we actually did on the spring. So we think it's area R. Area P we can eliminate because it's not even the area under the curve. So that's just straight out. Area Q is kind of this missing, is this Netherlands of work here. Clearly we can do more work. We did more work than that. So that takes out Q and R is out.